Hey folks, in this video we're going to return to the problem of trying to take a sum of different parts of an array from different threads. The difference though will be that we try to have independent memory allocations for each thread. This is ideal for thread speedup since it means that the threads won't fight over the same piece of global memory and instead we're able to put their own piece of memory in the different caches associated with the different CPUs they're each running on. In general, this means we'll have a potentially huge speedup over this scenario where they're all fighting for the same global memory. Okay, now the code we're about to write is going to be a little bit complicated, okay? We'll try though to explain it, but it will be a little complicated, so kind of brace yourselves. The reason why I use that tone is because all of a sudden we're going to really do some in-depth memory management in threading situations. Okay, so let me go back to our picture, and we started to draw this last time, and I think what I'm going to do is actually clean this up a little bit. So I'm going to draw off to the side, okay? So we know that we basically have P1, right? So P1, I'll make this a little bit bigger. P1 is our main process. So that's where everybody is obligated to kind of take information from. Now in the old design, we had basically everybody using the same memory from the same process. So our picture maybe looked something like this. So we have basically my infos array, right? So remember that. And then our data array. We'll glance back at the code really quick. So from last time, we had basically infos over here, data over here. So we have these two big pieces of data. And somehow how my picture would look is I had, for example, T1, and T1 had a reference to info, or got a pointer to info. T1 also got a pointer to data, right? Same thing for T2, right? T2 had a reference to data, and T2 had a reference to infos. So this is kind of how our original picture looked, right? And it was not ideal because they were fighting over memory. So what we want is something, it's going to be very different looking. Actually, maybe it's worth me just deleting all of that there. Instead, what I want is the following picture. I want different infos, right? So this is maybe info of 0, info of 1, right? So I want two separate pieces because before, right, we had an array allocation, right? So this means that there's an array, it's contiguous memory, so they're back to back, same piece, right? They can't ever be separate. So I want them to be different pieces. Okay, so I'll draw it a little bit like that. And I also want, right, this data over here to be separate pieces as well. So I want basically a chunk of 2 and a chunk of 2. That's really what I want. I mean, maybe if I'm trying to, be a little bit, specific here, is it'll be basically, right, I mean, there will kind of maybe still be this thing, right? Right, so this could be my data, right, where it's 334 here, 222 here, right? And what I really need to do though, right, is I need to break that down into pieces. So I need to have a 222 over here and a 334 over here, right? Where both these are separate arrays. Because then my picture will be revised. So T1 now knows about 334 and it knows about that little piece of data over here, right? T2 knows about that and that, right? The main process knows about everything, including the big piece of data, right? But I really want it to look like this because I have this, right? Well, you can picture it. It's almost like I can draw a circle around it, right? This is going to be something that goes on one CPU. This is going to be something that goes on another CPU, right? That's ideal. That's what I want, right? And that's going to be a little bit complicated for us to figure out. Okay, so we're going to try and do this, right? So I guess let's just go for it. So this line over here is going to be the same. So we're going to still have two TIDs. That's not going to hold us back. So what's going to be the trouble is basically our first part where we want to have the two different TIDs, right? This is going to be a little bit of trouble. Because before, right, we had the line. I'll just copy it down just so we can have it there for reference maybe for a second and think about it. We had originally this over here, right? So we have this over here. This is two that are contiguously allocated right next to another. So now I need to break them up. So I know, right, that fundamentally I have to have a malloc. Right, I have to have a malloc for these. The problem though is that I can't just do something like this, right? And I'll show you guys maybe your first thought. Your first thought, right, might be something like this. Let's do a malloc size of struct thread info, right? Because I want to ask, right, for memory, right? So I ask for the size of a struct, and maybe I just multiply that by 2, right? And so when you maybe first start to do this, you think to yourself, oh, I can just do this not too hard. Well, air quotes, not too hard. Something like this, right? And I'll write out the full line here so that we can see it and talk about it for a second. That's still there. You might think that you can do that, but this is a problem. The reason why it's a problem is you are still allocating both of those pieces together, right? You are mallocating one big piece. So if you do that, right, you are still going to get, well, drawn better, one chunk that has two indices in it, right? So this is not actually what we want, right? And it should kind of make sense if you think about it, right? If I'm asking for 2 times this amount of memory, well, that's going to be together. It's one big chunk. So I can't do it like this, right? This actually is not suitable for me because it'll give you that picture over there. So let's do something a little bit different. And this is where it gets a little scary. I'm going to make this a double pointer. So this is going to be a pointer to a pointer over here and a pointer to a pointer over here. And then this over here is going to be a pointer. So I had 3 stars, right? So instead of asking for basically data for 2 structs, I'm now asking for data of 2 struct pointers. Okay, let's draw this because it's complicated. I'll try to keep the line of visible as we do this. So the previous time, right, we had a picture like this where if it was 2 times, it was just times 2 in the basic struct. It's one big piece of data. My picture over here is actually going to look different. It's going to look, and I can add to the one I've already drawn, like the following. I am going to basically have, not that big, I am going to have an array of size 2, right? So you see that size 2 over there, right? So I did malloc a size 2 array there. This is actually what's going to be called infos, right? So I have a size 2 array, but infos is actually a pointer to this. Actually, I gotta adjust my picture a little bit if we want to do this in detail. Come on, infos, please move. Infos moves over here. I need to put both arrows in there. So infos is one variable. Its type is a star, meaning a pointer to a pointer, right? And so you can see I have an arrow here, right? There's 2 layers of indirection you're seeing. So infos is a pointer to a dynamic array that contains enough space for 2 pointers. Okay, so that's sort of my first level of indirection, right? So I have a pointer to an array of 2 pointers. Right? Then I go into my array of 2 pointers. If I go to index 0, I have a pointer to a piece of data. If I go to index 1, I have a pointer to the piece of data, right? And so this is going to be my setup here, right? Right now, I've kind of only allocated this over here, right? This is what that line allocates. I'm going to later need to go to infos of 0 and malloc this, and then malloc this as well, right? But this is my first step because I want to basically make sure that I have separate pieces of data. I don't want to allocate them together, right? That would be a problem. That gives me the big block like I had over here. I want to do them separately, okay? So this is how our infos now looks, right? And so like I said, this is a little bit complicated because we're using a double pointer. This is going to be the only time we need a double pointer though. Hopefully it kind of makes sense, right? We want to break them up. Okay. So let's go back to our data and kind of proceed. I think what we'll try to do is maybe get one thread working and then work on the other. This next stuff will be kind of the same as we had before. Let me copy it because I'm lazy. Let's grab length and data. We'll make this a little bit different looking. I'm going to call this all data. Okay, so that's just the stuff we had before. And so now what we need to do, right, is basically set up that struct, right? So I want to set up the struct with the appropriate info. And this is where we're going to need to go back and do another malloc, right? So we want to do basically, right, this allocation over here, right? So we're going to do T1 first. Well, I need to do that. I've already allocated that. Now let me allocate that, right? Right now there's not an arrow leading there because it doesn't exist yet. So what I'll do, right, is I'll go over here and I'm going to do now infos of 0 equal the malloc, right? So I want to basically now malloc my space for a particular thread info, right? So now this is like this, right? And notice I'm not going to multiply it by 2, right? Because I'm allocating them individually. I don't want to put them together. I want to put them to be independently, right? That's what I want. So I'll end up with something like this, right? So thread info pointer, right? That's my cast. I'm doing a malloc for thread info, and I'm saving it to that array, right? So now I get, again, this other chunk being created. So we should be good there. Now that's created, I can go inside of it, right? And this is a pointer, right? So if it's a pointer, I need to basically use another arrow, right? We didn't need to do that before, right? We didn't have pointers before, right? So we did a dot all the time. Now I'm looking at a pointer, right? Well, technically, infos is a double pointer. One pointer is used up by the indexing. The other pointer is used up by the arrow, right? Okay. So now I can set up the contents of it. So now I can do something like arrow start equals 0, right? I could do that. I can do infos of 0, arrow, end equal, what do we decide? I think it was length over 2, right? Length over 2. So that gives me, 0 to 3. So that should be good. Okay, so that's the start of my my struct, right? And I could, right, even start thinking about, doing this thing over here. All right, so I could potentially, think about doing my create and my join, and even I guess my result as well. It's like this. I'll just copy this down. We're not quite done with them yet, but I'll just copy them down for now. Before I can call that thread create, the issue is I don't have my data yet, right? So I want to split my data. Initially, right, I just have this big chunk here. What I want is 2 smaller chunks, right? So I got to figure out how to do that somehow. And so what I'll do is I'm going to malloc this and then basically copy from this big array into the smaller array, right? That'll be my process here. Okay, so let's start by creating our little mini allocation. So I'm going to do the following. I'm going to create an int star, and I'm going to call it t1 data, right? So this is going to be a subcopy of this portion of the array, okay? So I want to malloc just for the 334. So we're going to call that, so t1 data. Now I need to do another malloc here, right? So I'm going to do a malloc, and this time it's going to be pretty simple. It's going to be size of int, right? Size of int times length over 2, right? Because that's sort of like the length of the thing. So something like this. Right, that should be okay. Gonna need a cast really quick, so we'll cast this. These are just integers. We'll cast an integer star. So basically, right, I am going to have enough data here to store 3 integers, right? So that'll be a place that I can copy these to. So now, right, this other block of memory over here, this now exists, right? Now I need to just fill it in and then pass it to the thread. Eventually, right, I'll have something like this, right? I'll have infos of 0. Arrow data equal t1 data, right? So that's me basically remembering where that data is, that way I can give it to the thread, and the thread can process it as it wants, right? So I'll need that. Really what I need to do here, though, is copy it over, right? So I want to copy from the main data to basically this subpart that I'm working with, right? So I'll do int I. We'll start at 0 because we're at the beginning, and then basically we're going to go to I less than length, right? So we're going to grab kind of that first half of the array. Something like that. And then we can just go our T1 data of I equal all data of I, right? So we're going to go index by index and move one thing around at a time. Okay, so malloc a new piece, copied it over, then we basically saved it into the info struct. Now we have all the information we need, so now we can actually do a pthread create, right? So we'll do pthread create, TID of 0, that looks good to me. No argument, no attributes, excuse me. I'm still going to use the same runner function as before. We don't actually need to re-implement that. That's actually going to be the same as before. Okay, so I'm going to leave that here. Now it's just going to be more efficient because it sees different memory allocations, and so when the CPU scheduler goes to run, it can put one on one CPU, one another. They'll be completely independent. They won't fight for data, right? So all of this actually stays the same here. The last parameter will change a little bit. Because infos is a double pointer, I can actually get rid of one of the ampersands because it's already a pointer, and so it'll be happy with that. Okay, so we have that there. Let's then do the join. I think the join TID, that should be fine. We'll leave that alone, right? So we're still going to join the same TID, not use the result, and then we'll print out the result at the very end. And I'm going to go over here. We'll change that to an arrow, right? Because basically, like I said, this is a double pointer now, right? So one pointer goes to the brackets, one pointer goes to the arrows. Okay, so I'm going to cross my fingers here. We're going to run it, and we're going to see if we get the result. Hopefully, we get back 10. It might freeze. Usually, that's what happens. It might freeze if I miss something. It freeze or give like a dummy value. But actually, things look pretty good. And so now, right, basically, we have this left side of the picture figured out, right, where there's sort of a different thread info struct and a different piece of data it's operating on, right? So that T1 looks like it's going to be good to go. And like I said, this is going to be pretty efficient because the CPU will be self-contained, right? The memory is self-contained. We don't have to fight with somebody else. Okay, so we have a few more things to figure out here. I want to add T2, and then also we need to do some cleanup. So we did some mallocs here, right? So let's make sure that we free all those. There's 3 mallocs there, so I'll probably end up with about 3 mallocs at the end of this. First thing I need to free is going to be the data inside of the info struct that I gave, right? So infos of 0 data. Let's free that, right? So that free there matches with this malloc over here, right? So that gives back the sub data. And then we're going to free the info struct itself, right? So we want to make sure we get the stuff inside before we get the outside thing, right? Otherwise, we're going to lose a reference to it. So now I'm going to do infos of 0. Okay, infos of 0. That should be good there. And then the last thing is I need to free the 2D array that we created out there, right? So I'll do a free on just infos by itself, okay? And that should mean we clean up all of our data. We'll run it again real quick. Let's just see if we get a same result. And we do. Okay, so it doesn't crash. No seg fault. Okay, and we'll clean up that as well. So definitely a little bit more complicated than the previous approach, but it's much, much more efficient, right? So we have independent data for each of them. Let's, I guess, do thread 2, and then we should be good for this example. So let's grab this over here. So let's basically call this, what? Infos 1. Right, so this will be infos 1. There'll be T2 data. This is 2T data over here. T2 data, infos of 1. Okay, that looks okay. All right, well, I copied and pasted through some things. Let's make sure we're okay. That should be fine. This is not going to be fine. Okay, so our malloc is just the same. We copied that over. The start will be a little different, right? I think before we basically started, or we basically said we're going to start in the middle, right? So maybe something will look more like, well, wait a minute. Let me think for a second here. My thread start. See, I want to start in the middle, but also I just realized if I'm this thread over here, I'm really going to be starting at 0. So it actually makes my bounds easier, right? So 0 to 2. So actually, I was ready to do some math, but I don't, because each thread kind of sees the middle part, or sees a beginning it can work with. So T2 sees just this, it can actually start with index 0. So this is actually going to start at 0. So that'll actually stay the same. Length will even stay the same, right? They'll both go over those same subregions. So all of that should be good to go. The malloc will be good as well. The loop will be a little bit different because I want to copy this part, right? So I'm going to need to basically start later and run later. So I'm going to change this up a little bit. It'll go up until length, right? So I need to go to the very end. So I need to go up until 6. But then over here, for the beginning, I'll actually start at length over 2, right? So I'm going to start basically where the other one left off, right? So I'm going to evenly split it in half. That way I don't have any issues with balance, right? So start in the middle, go all the way to the end. Then these, right? So I is using the full length, right? So this means that it'll be a valid index into the overall data, right? Because that's how it lines up. So this is going to be a 0 to 5 indexed array on the right side. This is a 0 to 2 indexed array on the left side, right? So this is going to be valid for that kind of aligns. This over here, that'll need to be shifted a little bit, right? Because it's not really like when the thing starts in the middle, right? It's going to start at index length over 2. That should be the equivalent of my 0 in the T2 data, right? So if I'm looking at a 3, really I want to translate that to be a 0. Right, so length over 2 is a 3, so subtract 3 from 3 is 0. So basically I shifted over by the half the length, right? And that gets me kind of to the middle. Okay, so that should give me all the data that I need there. Now I can kind of repeat this other stuff. So I'm going to basically spawn a new thread with the new infos that we have just set up. And again, I'm hoping that everything there is correct. I believe it is. We'll do a join as well on this new thread recreate. And then we'll do a result over here. And I know that I'm pushing my luck by doing so many things in a row and not checking it. So let's go ahead and run it. Let's see if we get a result. Result is 6, right? So you can see it's adding up the other side. Last things I need to do here is basically clean up the memory allocation. So in this case, basically I'm going to go to infos of 1 in both places and free it, right? And then this stays by itself, right? That freed an outside array that was of size 2, right? So that stays the same. Okay. And there we go. That is our little program there. We'll run it one last time just to make sure. And yeah, we should be good to go, right? And so just to kind of recap what we're doing, right? We're overall, right, making this thing more efficient, right? The idea is we want to go from the picture on the left, where basically data was one chunk, info was one chunk, both threads would fight over it, to be in this picture on the right, where the allocations are independent, right? I have a little bit of data in T1, a little bit of data in T2. They each have their own thread info. They don't have any competition with one another. They can run truly independently on different CPUs, which is going to be optimal for us, okay? So the functionality is the same, but the performance is vastly increased in the stuff we've just done. All right, that's all I got for this video. I know it's a little bit to unpack. Hopefully, right, the video helps and you can stop and replay and try the code on your own and see if it works or not. So I will see you guys in another video. Later.